perpendicular distance, so let's take a look. We're trying to find the spin about the y. There's the 80 Newton.
So you're going about the y?
Yeah, so it's going this way, so the perpendicular distance would be 250, no?
Yeah.
It would be what?
Let's see, we're trying to find the spin about the y-axis.
Yeah.
So here's the 80 going this way, and then the 80's going this way, so it's causing a spin about the y-axis. The perpendicular distance would be 250. So 250 times 80, and would it create a positive or a negative spin? It would be a positive. So what's 80 times 250? That's 4 times 250, that's 1,000.
20,000.
Thinking in terms of money again. 4, 25 is 1,000, and 2, so it'd be, is it 20?
Yeah. 20.
Did somebody get 20? Somebody else got it? Okay. Okay, let's try the next one. So 80, the absolute value of 80, and now we're trying to figure out the spin about the z-axis. So the perpendicular distance would be what? If we're trying to find the spin about the z, the force is in the x, the distance has to be in the y. It's got to be 375. And does it create a positive or a negative spin? Positive. So what's 80 times 375? Is it 30? Okay, great. Okay, 75. Always show the work, okay? So 75 is in the z, and we're trying to find the spin about the x. If it's the spin about the x, if 75 is in the z, and I'm trying to find the spin about the x, this has got to be in the y. So 75, and the y distance is 375, that's correct. I'm trying to find the spin about the x, and it's positive, 28.1. Did somebody else get that? Okay. Let's do 75 in the y. So 75, again, is in the z. I'm trying to find the spin about the y. The perpendicular distance would be in the x. It's times 200, and it's negative. Somebody get that? Okay, so should we convert since everything? The columns were in millimeters, so we probably should have left everything. So it looks like everything's given it to me in meters, so let's change the units up top. And is that 115? Okay. So you don't need to put units in here now, because they're all up top. Okay, how about the 100 Newton? 100 Newton is in the y. We're trying to find the moment in the x. The distance has got to be in the z. It's 250. Trying to find the moment in the x, 100, 100. I got a negative. Negative 2,500. Somebody else get that? Okay. And then let's do the last one. So the what, Isadora?
That's minus negative.
Okay. So it's 100, and 100 is in the y. We're trying to find the moment in the z. So the distance has got to be in the x. 100, moment in the z, distance is in the x, it's got to be 200. Is it a positive or a negative? I see a negative, so negative 20. Did somebody else get that? Okay. And then we have to do the total, right? So what's the total? We add this up. This is a positive 28.1. This is a 25, so it's 3.1. And then this is 5, and this is 10. So my moment, the sum of all the moments is 3.1i plus 5j plus 10k, and what's my units? Newton meter. And then this is represented as what? Vector form, so then I could also represent it as magnitude and unit vector. What would magnitude be? It would be 3.1 squared plus 5 squared plus 10 squared under the radical. What's that turn out to be? And then I would have to find theta x, theta y, and theta z. What's the magnitude? Say it again, Kelly? 11.6? Newton meter. And then we would solve for the theta angles.